So Metcon's based in Monaca, Pennsylvania. We're about 30 miles north of Pittsburgh. We want to refer to it as the Titanium Valley. So there's a whole lot of titanium processing that happens right here in western Pennsylvania. We actually have our headquarter facilities in Monaca, and we have an R&D facility out in Colorado Springs, Colorado. It's smaller, scaled with very sophisticated equipment to do developmental processing. Pickling is a term that's broadly used to be an acid cleaning on metals. When you get into the specifics of titanium, there are two typical techniques. One is a straight hydrofluoric acid bath, or the more common is a hydrofluoric and nitric acid bath. It can also, longer durations in the bath, help find defects that are subsurface. Sometimes the industry uses it as a defect reveal underneath the ground surfaces. And then in final products, it's often required by customers to have a final product pickle, and that's again a surface cleaning, a surface contamination removal, as well as to some extent to smooth the surface so that it can have better cold formability than the just as machined or as ground surface does. Important to know that in titanium, from the ingot that we melt to the piece of bar, sheet, or plate that the mill producers sell, we only yield about 65–70%. So 30% of the metal is gone away, is removed as some kind of a waste material. That's typically because of the conditioning steps, where they're grinding away or machining away these surface layers, where the typical removal is in the range of 5, 6, 7%. Today, Metcon's pioneering in this field of electrochemical processing of titanium. It's very, very different from the typical conditioning steps that go on in intermediate conditioning of titanium products. What we are doing is an electrochemical surface conditioning. Instead of driving the crack any deeper, we simply open it up and feather it with the surrounding metal. And by feathering it, that allows you to preserve all that metal adjacent to the cracks that routinely is either ground away or machined away. But we do that all in a very benign bath, a weak acid chemistry, and control the reaction with a rectifier. So it's very different in how we go about it. The main driver and why people want to use us, it's all about yield. The cost makeup of titanium is very heavily driven by the yield losses, and those yield losses most typically are coming from the grinding steps or the machining steps in the intermediate conditioning. So if you just simple math, you think about you do 3 or 4 times that I have to grind away 5, 6, 7% of the surface, and if I take that 5, 6, 7% and reduce that to only 1 or 2% that gets removed when I use the Metcon electrochemical approach for conditioning, that's a dramatic yield improvement. We're talking in typical from ingot to finished product. If you use Metcon for each of the conditioning steps, a routine 15% yield improvement. That's 15% more metal that wouldn't have been there, that's hazardous waste otherwise, that we provide that's saleable product from that original ingot. So it's yield, which means cost. It also means capacity. If you look at it of I get 15% more metal from the ingots that I produced, that means that I basically installed another melt furnace that I paid no capital money for, simply because I now am getting out the capacity of 15% more product. Real dramatic change. It's one of the biggest changes in the titanium industry that they've had available to them in years. And then throughput, because we are combining a step, we're taking what is historically been a grinding step that's very, very slow, that takes a shift and a half to condition and heat a metal. We're reducing that to an hour, hour and a half sometimes much less. We can save the throughput just on the activity-based throughput, and then at the same time, most of those grinding steps or bar peeling steps are followed by a pickle operation. We take that entire pickle out of the process altogether, so you remove and eliminate an entire step. That quality throughput both is that we're detecting more defects that are subsurface and hidden. We're more complete in the reveal. It's a very clear black line if there's a left behind alpha case or defect crack. So we more completely reveal them, and that delivers a benefit in the downstream yield. On top of the activity-based yield, there's fewer cracks that are occurring in the next processing operation. So in terms of products, today our customers send us all forms of intermediate mill products. We spend a lot of time working on as melted slabs. We currently condition the majority of melted slabs in the American industry. We also do an awful lot of intermediate conditioning, whether that's large octagons, intermediate round-cornered squares, or re-roll bar or re-roll plate. We do all of those steps for different customers along the way. We do have some customers for whom we do finished product final pickling. And now, recently, we've had an awful lot of interest from companies that are actually into the parts manufacturing business. We are still a very young company that has really been installing and pioneering how do you do electrochemical conditioning. You know, as the needs have arisen, we've added different rectifiers, different capabilities. We installed a blasting line, and the investments are ongoing.